So the next presentation will be actually remote from Tasuku Honjo, who couldn't make it because of health issues. And he was kind enough to record a presentation which he actually recorded twice because he didn't think that the first one was perfect. And we got the second one just yesterday evening, 2 days ago, actually. And so, please.
I'd like to express my sincere appreciation for inviting me to this wonderful symposium on cancer and immunity in the Collège de France. I'd like to express my apology for not attending in person, although I very much wished to do so. Today, I'd like to talk about a new dimension of PD-1 blockade therapy against the cancer. You all know, so I don't need this introduction, but cancers express large number of so-called neoantigens, which are captured in dendritic cells, and actually those antigen expressing tumor cells are attacked by T cells and released antigen, and that is captured by dendritic cells. And those dendritic cell expressing antigen is recognized by T lymphocyte, and that's where the story begins. So in a way, this is a circular system, recognition antigen on DC, and this activate T cells go into lymph node and recognize cancer antigen, reactivate it, and circulate and go to the tumor site. The limitation is the negative regulator, and that try to avoid activation of T cells. So this is where the PD-1 antibody have the effect. PD-1 blockade is basically reduction of threshold of activation. So even though the T cells recognize the same antigen, in the absence of PD-1 blockade antibody, the response is very weak. But in the presence of PD-1 blocking antibody or other reagents, this induces strong enough stimulation to T cells that can go into the tumor site and attack. And even on that phase, PD-1 and PD-L1 interaction can suppress T cells. So this strategy, reducing the activation threshold, was effective large number of tumors. And since first approval for melanoma, 2014, more than 2,000 cancer cells is now approved as a target for PD-1 blockade therapy. So this strategy made kind of paradigm shift in cancer immunotherapy. First, less adverse effects compared to chemotherapy, irradiation, and many others. Effective for a wide range of tumors by single drug. This is totally different from the other chemotherapies. In addition, it has durable effect for many tumors for which this drug showed effectiveness. So even they stop the administration, the effectiveness continues and tumors do not regrow, or sometimes completely disappear. Why this is so effective? Now this is because almost all tumors express so-called neoantigen that are created by accumulation of mutagenesis. During extensive or rapid proliferation of tumors, they mutate various proteins and express new antigens. So, what we learn from extensive cancer genome project is this. All tumors, massive accumulation of neoantigens. And this is the basis of cancer immunotherapy. In addition, it's very difficult to pinpoint dominant mutation because the mutation continue to accumulate and it's not a clone. So for example, if you treat a tumor with drug A, certainly you can kill those target cells specific for drug A, but other tumor progenies or derivatives or mutants continue to grow. And now you change drugs, you still see additional clones growing back. However, lymphocytes can recognize many mutations or neoantigens. They all recognize each clone and kill or attack. So it looks great. However, we all know this is not the end of the cancer. We have several targets that has to be overcome. We wish to know whether there was any good biomarkers because obviously not everybody responding. Currently, roughly 20 to 30% of cancer patients are responding. Now, of course, we wish to have new strategy. The two approaches are mostly popular. One is increase accessibility of killer cells to tumor sites. This is particularly important in tumors like pancreatic cancer. Of course, we need some additional treatment to increase killer T cell function. Today, more than 2,000 or 3,000 combinatorial clinical trial is underway, and most of them PD-1 blockade plus chemotherapy, CTLA-4 blockade, radiotherapy, and many others. Today, I'd like to show you some interesting new data, but this is not new. Everybody knows immune function is very high at the early stage of our life and gradually goes down. In mirror image, incidence of the tumor goes up. So we wanted to reproduce this animal system. In fact, many experiments so far done are used young animals, and PD-1 blockade works beautifully. However, if we use aged animals like this, 16 months old, it doesn't work. So aging is very important for tumor and tumor survival and patient survival and treatment efficacy. And this is not because of antibody. We tested similar thing with knockout animals. Again, aged PD-1 knockout animals allow the tumor growth and more early to die compared to young animals. And human, also several studies, actually many studies, indicated many tumors, lung cancer, head and neck tumor, stomach cancer, show the aged people less susceptible to PD-1 blockade. And two types of hypotheses have been available to explain this. One is we lose thymus in early stage because repertoire shrink. The other is there must be some regulation because we have T cell repertoire similar to young age because of homeostatic proliferation, meaning self-antigen is the source to maintain our T cell repertoire. In fact, we found that the repertoire is okay, but there are several mechanisms to avoid autoimmunity by suppressing the sensitivity to antigenic stimulation. I believe this is a major reason to avoid autoimmunity. So we wondered, there must be some mechanism to regulate immune response in aged animals. And there are many known molecules involved aging or longevity, vice versa. One of them is spermidine. This simple molecule, member of polyamine, has a long history and has been claimed to play a role in aging in series of animal models, including Drosophila, mouse, and some people claim human as well. Spermidine is synthesized from arginine and by series of the biochemical steps shown here. And human also, this amount of spermidine is reduced with aging in serum and also in urine. So we tested whether spermidine is in fact reduced in aged CD8 T cells in animals. And as you can see here, serum spermidine level is certainly reduced. And this, I already showed before, the aged animals, they are not responding to the PD-1 blockade. And we tested whether this insensitivity to PD-1 blockade can be overcome by addition of spermidine, because aged animals are spermidine deficient. As you can see here, yes, the spermidine addition clearly helped growth, suppression of tumor growth in the presence of PD-1 antibody. And this is confirmed the presence of more T cells in tumor site, as you can see in the lower half of the slides. We asked why this happens. We found spermidine actually helps with fatty acid oxidation in mitochondria. In aged animals, somehow the mitochondrial oxygen consumption rate is reduced. And especially the fatty acid oxidation level, which is detected by blocking the first step of the fatty acid oxidation by atomoxia antagonistic chemicals, and then spermidine effect is blocked. So clearly, activation of mitochondria by spermidine depend on fatty acid oxidation. So we thought spermidine may have some target and did a very simple biochemistry. Spermidine coupled to beads was mixed extract of T cell and precipitated and eluted with spermidine and detected the difference between spermidine plus minus. And these bands isolated and sent to mass spec and detected several proteins. And we constantly detected the protein derived from mitochondrial trifunction protein, MTP. And this protein is very important for the fatty acid oxidation. The early stage of fatty acid oxidation is carnitine-mediated transport of fatty acid coming into the mitochondria, and the first enzyme is MTP, which catalyzes 3 steps of the reactions. And so these proteins actually compose alpha-2 and beta-2 subunits and mediate 3 steps of reaction. So what we did is further biochemistry, express these proteins in E. coli and purify them homogeneity. And this is consistent with the molecular size of the reported protein. And this is homogeneous. So then we tested whether this protein actually binds spermidine. So E. coli synthesized and homogeneously purified A and B subunit respectively tested for interaction with spermidine using the physical chemical method. And maybe you can appreciate here. The green color curve is the assumption. Actually, this is alpha 2 was only fixed. Beta 2 was aggregated and cannot be used for the experiment. So alpha 2 clearly form the curve equivalent to one-to-one interaction. Alpha 2 dimer protein binds to spermidine. So spermidine definitely interact A, and using purified protein, we could test it, whether this enzymatic reaction can be enhanced. And yes, it does. It enhances, especially Km of the reaction in the presence of spermidine. So thus, this small molecule shows allosteric activation of MTP A and also B, another type of reaction. This is basically the same thing. By increasing the amount of spermidine, you can get accelerate reaction and increase, reduction of Km, meaning affinity binding. So finally, we wondered whether this enzymatic activation of MTP is really responsible for anti-tumor efficacy enhanced by spermidine. You can appreciate we generated the flux animals, and the animal lane 3 has no MTP protein, actually in this case HADHA. And in this animal, compared to wild type, below is the knockout animals. It loses spermidine augmentation of oxygen consumption rate. And most important, here you can see on this side, even you see the spermidine in the wild type or heterozygote, it loses effect of spermidine. So we conclude spermidine augmentation of anti-tumor activity of PD-1 blockade is because of targeting MTP protein and enhancing fatty acid oxidation. So this very interesting enzymatic system as a complex helps with T cell function vital to anti-tumor immunity. In summary, age-derived immune suppression is one of the unresponsive factors for PD-1 blockade therapy. Anti-aging polyamine spermidine rescues attenuated mitochondrial fatty acid oxidation aged T cells by directly binding to MTP. So I don't say this is the only mechanism or whole mechanism of spermidine, but at least this is very critical to anti-tumor activity of T lymphocytes. I'd like to thank the collaborators. I can't tell all the names, but Muna, who made a major contribution from Oman, is here. And I'd like to thank for your attention.